Hey guys, so today we're just going to look at circles and geometry. Okay, so we just need to run through some terminology. A lot of this you should remember from the coordinate geometry of a circle, but maybe some of you have forgotten it. So first of all, we have that, so you can see I took this diagram from your book because it's just perfect for this. So the radius is the line segment from the centre of the circle to any point on the circle. So it comes from the centre point. When we were talking about coordinate geometry of the circle, that centre point is normally at 0, 0. And then the radius is from that centre point to any point on the circle. So if it's from here to here, if it's from here to here, if it's from here to here, they're always the same length. Okay, that's really important to be able to identify a radius or radii. A diameter, then, just to quickly jump on to diameter, is a chord that passes through the centre of the circle. So if you were told how long the radii was, or you're given the value for the radii, you'd only have to double it if you could see or if you could identify a diameter. A chord is any segment that joins 2 points on the circle. So a chord can be through the centre point O, which is then called a diameter, or it can be something like this, where it kind of just cuts a small segment of the circle. Again, just want to give a little recap on this. You can fast forward the video if you're happy enough. Circumference is the perimeter, the length of the circle. When we're looking at area and volume, we'll be looking at the area of a circle, and we'll also be looking at using the formula for the circumference. An arc is any part of the circumference of the circle, so it can be something like this. You'll remember, and we'll have a quick look at that now in a second, the theorem that we studied that had arc basically in the heading. We'll talk about it in a second. And a tangent, a line that touches the circle at only one point, and it's on the outside of the circle. Okay, so it just touches the circle at one point. Now, I'm going to just show you a corollary that relates to a chord, but it really, as long as you remember the circle theorem, you should be fine. Okay, with circles then as well, a corollary for if the angle standing on a chord BC, let's say this is BC, you can just write in BC, at some point of the circle is a right angle, and then BC is a diameter. You could also use, you don't even need to remember that corollary, because we talked about this theorem here. And this theorem says that an angle standing at the centre of a circle, so an angle like so, which we know is a straight angle, okay? So that's a straight angle, 180 degrees. Angle is twice the angle on the same arc, and we can see that this angle is on the same arc. So it's on the exact same arc because it goes B to here to C, and our angle here goes from B to C. So if this is twice this angle, then we know that has to be 90 degrees. Okay, so just an example of a couple of questions using that knowledge we have now. So if we look here, we can see that this is a 180 degree angle. So if I want to find out what angle 1 is, then I know for a fact that's going to be 90 degrees because of my circle theorem. The angle standing in the centre of the circle is twice the angle on the same arc. Now I know that that's 90 plus 40 plus angle 2 should give me 180 degrees. So 90 plus 40 is 130. So angle 2 is equal to 50 degrees. Okay, so here's the thing with this. I know some of you will see this and absolutely freak out. I can't do it. But what I will say to you is fill in the information that you know. So look at this. You can see 3 triangles. You can see a circle. You know some little bit of knowledge about angles and circles and triangles. So let's work with that. So it doesn't matter where you start here. If you want to pause the video and try and figure this out yourself, that's fine. And then come back and see how I did it and see maybe you've done it a little bit differently. If we look at this, the first thing that I would notice here is that they've told me that these are parallel. Okay, these little arrows mean they're parallel, so I could use that. More importantly, this angle here I can figure out because I know the value of the other two angles. So the other two angles, 180 degrees is that whole triangle, and from that I'm going to subtract 105, and I'm also going to subtract 37.5 degrees. And what I'll get is 37.5 degrees. And I actually should have known that because, so 37.5 degrees is this angle here. I should have known that. Why should I have known that? Well, if I look, I can see that here and here are radii because they go from the center point to a point on the circle. And this one goes from the center point to the center on the circle. So they're actually the same length, and that would mean that this triangle is isosceles. So this is an isosceles triangle. But that's okay. What I was going for was that that's 37.5 degrees. And then as a result, I should know that from alternate angles, because of that Z shape there, so you can see this Z shape. I know I'm getting very messy with this now, sorry guys. So from this Z shape then, I would know that that's going to be 37.5 degrees as well, okay? And then on that basis, I can use so many different ways of finding out angle 1 here. So what I can do is I can say that, let's just scribble off some of this writing here for a second. So you can take that down, or you can just pause the video to take that down. Okay, so just so we can see this a little bit better, I can see here that if I turn this triangle to one side, so you could do this in an exam, just shuffling your page around. If I look here, I know from what I've just learned about triangles that all of this here would add up to 180 degrees. I already know that this is 37.5. I know that if all of this adds up to 180 degrees, then all of this blue area here should add up to 90 degrees. So what I could do there is I could say 90 minus 37.5 will give me 52.5, and that's my angle 1. Now there's loads of different ways that you could do this. So if we just turn this back around, other people might decide that they would, I'll just bring this, make it a little bit smaller so you still have that. Other people might decide that they are going to find out what all of these angles are. So we could use the vertically opposite angles here to find out O. Then we could find this and this and subtract from 360 and find this and this. Then that would give us, we could use our Z here to get this angle, and then eventually get this angle, and then eventually get this angle. So there's so many options that you have there. There's so many different ways of approaching this. It does not matter, even though they asked us just for 1 and 2, it does not matter if you go and you find some of these angles here, or even this one out here. If it helps you find 1 and 2 in the end, it does not matter. It's whatever way you see a question like that and figure out. And it's all based off your knowledge of geometry. So that's why it's really important to revise the theorems and the corollaries. This is only part 1 of circles. We have a couple more bits to cover. But for now, just go ahead and attempt the homework that I've uploaded.